Okay, welcome everyone to a little video on how to catch statistical cheaters, right? And unfortunately, in statistics, there are ways to cheat, but you can also catch those cheaters, which I will talk about today, okay? And there are three main ways to cheat in statistics. You can manipulate the inputs, that's what I'm going to talk about today. You can manipulate the calculations and manipulate the outputs, which I will talk about in two other videos. Okay, so this is our topic today. Okay, and some words of wisdom before we start. Take it from an old guy like me and an even older guy like Immanuel Kant, who said in his categoric imperative, never cheat. And that's what you should do. Be honest, value the truth, because it's the right thing to do, and often cheaters get caught. And how to do that in statistics, I will show in this little video. Okay, so today we're going to talk about how to manipulate the inputs and catch those input cheaters. And there's three ways you can basically do this. You might have heard about data snooping or time frame snooping. We can take a sample that is biased, or we can talk about how if it is okay to eliminate outliers. Okay, so that's basically our agenda. Okay, let's talk about data snooping, also called data fishing or data dredging. And here's an example. First of all, a definition. Data snooping is selecting data for which the research hypothesis works. Okay, and here's an example. We have PhD student Hans, who wants to prove that smoking does not cause cancer, since his research is funded by the tobacco industry. His data pool of 1,000 smokers and 1,000 non-smokers shows that a significant number of smokers develop cancer in later years when they're older. Therefore, he conducts his research for individuals under 30. Since few individuals under 30 develop cancer, the research concludes that smoking does not cause cancer. Okay, is that data snooping? Definitely, right? Because Hans only does his research on selective data, which is not representative of the whole population. So this is data snooping, and it's statistical cheating. Okay, and in a second I'll show you how to catch those cheaters. Okay, yeah, smoking, never a good idea. Okay, similarly, there is time frame snooping. Definition: time frame snooping is selecting a time frame for which the research hypothesis works. Okay, here's an example. So here we have two functions. Here we have the S&P 500. So that's kind of the stock market in the United States, 500 stocks up from the stock market. And here we have the treasury yield, so the government bond yield. Okay, and what can you see here? Well, you can see the functions are negatively correlated here from 1998 to 1998, 88 to 98. Actually, the correlation coefficient is minus 0.4. And then we have a positive correlation in this area here where the correlation is plus 0.6. You can see the functions are moving in tandem. And we have a negative correlation again here. Okay, so what's the takeaway here? The takeaway is, well, a researcher, if he selects a certain time frame, can prove that these functions are negatively correlated if he uses this time frame or this time frame, and a researcher can prove that or show that these functions are positively correlated when he uses this time frame. So unfortunately, correlations are very time sensitive and change in time. Okay. Yeah, how to catch those data snoopers and time frame snoopers? Well, see if the researcher justified his or her data selection, right? Okay. See if the data selection is reasonable, or if the researcher took a time frame that is very unusual, maybe 20 years ago, just for a time frame of a year or so. See if the data and time frame selections are sufficient meaning typically the more data we have in the study, the more credible is the statistical result. Okay, so if a scientist uses very little data, that raises a red flag. And importantly, see if the researcher has done out-of-sample testing, right? So has he taken his hypothesis, tested it with certain data, and then tested that research hypothesis with different data out of sample? And that's important. Okay, second topic, biased sampling. Okay, so that's also another way how a researcher can derive results that he desires. Okay. Definition: biased sampling, also called selective sampling or convenience bias, is using data from a non-representative sample of the population. Okay, and here's an example. To determine Trump support in the United States, we polled bikers at the annual biker rally in South Dakota. Right? Here's a nice picture. And it's a pretty cool event. There's about 500,000 bikers that come together every summer in South Dakota, and they just celebrate their passion for bikes. No? If you would poll Trump support there, you would probably get a very strong, a very high support, because Trump supporters are usually white males without a college education, and you'll find a lot of those at that biker rally. Okay, so this sample would not be representative of the US population. No? And vice versa, to determine Trump support in the US, we sampled students and professors at a liberal university. There you will get the opposite effect, very little support. But both samples, we can argue, are not representative of the US population, and so the results would be false. Okay? Here's another example, involuntary biased sampling. In the early days of polling in 1936, the US Literary Digest magazine predicted that the Republican presidential candidate Alf Landon would beat the incumbent FDR, Franklin D. Roosevelt, by a wide margin. However, the sample voters consisted mainly of readers of the magazine, who were mostly wealthy Americans leaning towards a Republican president. FDR won in a landslide. So this is also an example of a sample which is not representative of the whole population. No? Okay. How to determine if a sample is biased? Apply common sense, right? So again, if we sample at the annual biker rally, that is not a representative sample for the US population. No? See if the researcher justified his choice of the sample, right? And if he has, that adds credibility to the study. See if the sample is large enough, right? A small sample, of course, raises a red flag. See if the researcher did out of sample testing again. So tested their hypothesis with data different from the originally used data. No? And if possible, do your own out-of-sample testing, or let your unpaid intern do it. Okay? Okay, we already come to topic number 3. What shall we do with outliers if we have an outlier in our study? Okay? And if I ask my students, what shall we do with outliers, I often get the answer, get rid of them. That's not the correct answer, right? Because if you have an outlier, here we have one actually, and the outlier is not erroneous. The outlier is part of the data series, and you cannot just eliminate it. That's data manipulation or statistical cheating. Okay, so here we have a relationship between marketing and sales of Mephisto LLC. Data could be in $1,000,000, and you see sales and marketing here. And this graph is not very favorable for the marketing team because we have a negative regression function here. Okay, meaning the more marketing, the less sales actually. Okay. And now the marketing team decides to get rid of this outliers. So let's see what happens then. Okay, so they just eliminate sales data under 20 million. Here we have 20 million, so this point is eliminated if sales data under 20 million is not incorporated in the study. And we get a very different result. We now have a positive regression function, right? So the marketing team can argue, the more marketing, the higher the sales. Okay. However, is this statistical cheating when we get rid of an outlier? And the answer is yes, right? If the data point is valid, then we can't just ignore it. That's data manipulation or statistical cheating. Okay. Here you have another result of outliers, and we can compare mean and median, and we'll see that the median ignores outliers, and that is questionable. Okay, so here we have students. They have a test result of these numbers here, 27, 30, 31, 32, and 3 very good students, which all get 100. Okay, so we calculate the mean, which is 60. So we just sum them up and divide by 7. And then we can take the median, which is just the middle value of a ordered number series. And I ordered them here already. Here I ordered them again. And here the median is 32. Okay. And now the question is, what is the better concept to derive the central tendency of the class? Or in other words, on average, how is the class doing? Right? And we can argue the mean is a good number, a good value that tells us how on average the class is doing. However, the median ignores these 3 outliers here, right? So the median tells us the class on average is doing very badly. The average is 32. But that is misleading because these 3 outliers are not incorporated in the median, right? So that is a questionable statement when you say on average the class is performing 32 because we ignore these outliers. Okay, I have another example here. Hedge fund doomed has the following returns. Okay, so in 2015 it made $500,000, in 2016 it made $3 million, and so on, and we have a big outlier here in 2020. Okay, if we calculate the mean, we get that an investor who has invested in this hedge fund starting in 2015 until 2021, on average each year, so per year, loses $500,000. Okay, and that is a reasonable, a credible number. However, if we calculate the median, we ignore this outlier here, right? And the median here, so the middle value of these ordered time series is 3. So if you tell the investor, well, on average each year you made $3 million, that is very misleading, because on average the investor didn't make $3 million per year, it lost $500,000. So that's why I'm not a big fan of the median, because the median ignores outliers, the numerical value of outliers, right? This could even be 1,000, right? 1,000 million, so a billion that the investor, that the hedge fund lost, right? So the median ignores outliers. That's the takeaway, and this can be statistically very misleading. Okay, how to deal with outliers? Unless outliers are erroneous, they are part of the data pool and cannot just be eliminated. That's data manipulation or statistical cheating. The median ignores outliers and can therefore be misleading. For example, a hedge fund can report inflated returns, like in the previous example. Outliers are actually overweighted in the standard Pearson correlation model. That's the standard correlation model which you learn in statistics, since it is based on the variance, right? So if you have an outlier here, let's say the mean here is 0, and you have an outlier of xi might be 10, so it's 10 minus 0. And then the outlier squared is 100. So the outlier of 10 enters as a value of 100. So the variance actually overweights outliers. However, this is not a justification for just eliminating and ignoring outliers. Okay? A remedy is to calculate the regression coefficients without and with the outlier. So that gives us valuable information. Principally, the more information we have, the better. And calculate the mean and the median, which is the same thing. You calculate the central tendency with a mean, which includes the outlier, and with a median, which excludes it. Typically, the more information you have, the better. Okay, let's conclude. What did we learn? Numerous types of manipulation exist. Input manipulation exists. Data snoopers and time frame snoopers can be spotted with common sense measures and convicted with out-of-sample testing. So you have to test the research hypothesis with out-of-sample data, so different data than the originally used data, or a large data pool, right? Again, the more data, the more credible the statistical study. Bias sampling can be spotted applying the same measures, right? Use common sense, do out-of-sample testing. Outliers should not be eliminated unless they are erroneous. The regression can be calculated with and with outliers, so again, the more information you have, typically the better. Yeah, there are 2 more videos to come on manipulating the calculations and manipulating the outputs. And here, if you want to read more about all this, there's a very, very good book which you can have a look at. Okay, thank you. Did I get my email?